This is the operator training for Windows Azure SQL database deployments. An operator responsible for performing deployments on a SQL Azure on Windows Azure database system will have the following responsibilities. They are responsible for general deployments, able to understand key configuration files, and able to perform some of the following deployments: configuration, data, application, certificates, and portal deployments. To accomplish this, they will need to use some of the following tools: XTS, CSManage, and MShell. We'll be looking at the following items in each module. Module 1 will have a deployment overview. We'll be looking at deployment terminologies, the workflow, and what is deployed, walkthrough of key configuration files, and have an introduction to certificates. In Module 2, we will be taking a look at the tools used for deployments. This diagram is a quick recap of what was covered in previous modules. It presents a view of the SQL Azure on Windows Azure system as seen from the perspective of Windows Azure. At the bottom, Windows Azure handles the basic real estate, provisioning, operating system, and general infrastructure services. In the middle, the Windows Azure SQL Database Service Platform handles all of the aspects of SQL Azure, including the back-end database, the metadata for all customer databases, gateway nodes so that customers can access their databases, and all the general management infrastructure services needed to operate SQL Azure on Windows Azure. This is a diagram that presents some of the tools that are used to manage SQL Azure on Windows Azure. An operator is expected to use items such as XTS and the client API and management tools that are provided, such as MShell, to contact the command gateway in order to issue commands to a SQL Azure on Windows Azure system that will then manage items such as deployments or machine health overview. The basic flow of a deployment through this system is that builds are grabbed from a drop area, usually a network share, and MShell accesses these builds, then accesses config store to draw in whatever configuration items it needs, pulls these items together into a single package, and uploads them to the image store, which is hosted by Windows Azure. It then issues a series of deployment commands through the command gateway to the cluster manager, which then continues with the rollout. As a deployment rolls across the system, the cluster manager instructs each node on the system to grab a copy of whatever it needs from the image store and deploy it locally on the machine. These items can include such things as service binaries, data packages for these service binaries, or configuration files for the services. Presented is an example of some release terminologies used by SQL Azure. An SU refers to a service update. A service update can include bug fixes or it can include feature releases. A service update is typically issued once a month. An AOD stands for Azure On Demand Fix. These are urgent fixes, usually due to priority 0 or priority 1 bugs that have been discovered after a service update has been deployed. This is a general overview of deployments. After a final build is issued, it is given to an operations department for scheduling. The operations staff will refer to the release notes that are provided with the build and coordinate with any other rollouts taking place within Windows Azure. Once the schedule has been established and a window has been set, the operations staff can begin deployment, monitor for any alerts or errors that they find during the deployment, and attempt to mitigate them if possible. If they can, the deployment will then be completed. If they cannot, then these alerts must be referred back to Microsoft so that they can be mitigated or an AOD can possibly be issued. Once mitigation or a new AOD arrives, then the process will repeat itself and go through scheduling again, and a new deployment will begin. The general deployment workflow will be that a partner will receive a build from Microsoft. The build should have been tested and deployed into Microsoft production servers already. Therefore, the build should be in its final state and not require any immediate AODs or patches. Partner is then responsible for scheduling the deployment using the release notes as a guide for deployment time estimates while maintaining awareness of any other Windows Azure deployments. One thing to note here is that often Windows Azure can perform infrastructure-related deployments, such as operating system upgrades and things, that can interfere with a SQL Azure deployment. These things should be scheduled independently of each other, and in general, SQL Azure deployments will require some infrastructure operations that need to be scheduled completely independently from any Windows Azure deployment, even just general support deployments. Once the deployment begins, its progress should be closely monitored. Alerts should be mitigated if possible, and if not, then the build should be rolled back and Microsoft should be contacted. What is generally deployed? An application deployment will refer to config changes in runtime services, data that is consumed by these services, certificates used by these services, or application binaries. An OS and patch deployment refers to infrastructure upgrades managed by Windows Azure but initiated by SQL Azure. And an example is an operating system update or a patch to that operating system. Portal update refers to the aspect of the Windows Azure portal that manages SQL Azure. This is a general overview of how we deploy. SQL database deployments have three major components. We have SQL database configuration files, and this set of files define the service model and runtime configuration settings. These base configuration files are distributed along with the build and should not be altered or touched in any way. The config store configuration refers to any operations-owned configuration files that are stored in an access-controlled location and used by various tools to manage the cluster. These files are typically maintained on-site and are available for editing by any operator. Then there is the actual build. MShell, which is a tool that we will cover later, is the tool that is used to deploy SQL Azure's database. It will read its configuration from the build and the config store in order to deploy. It is always distributed along with the build itself. And the MShell version that comes with the build should be the version used to deploy that build. The build also contains binaries, schema, and operational data necessary for the operation of SQL Azure. SQL Azure database depends on several different types of configuration files. All of the deployments depend on several key configuration files in order to build the system. There are two general types of configuration files. There are those that are developer-owned, and these are provided with the build as referred to before. They define the service model, which is what gets installed, as well as all recommended configuration. Then there are operator-owned configuration files, and these files are managed by the operations team, specify customer-specific configuration values, items such as local DNS names, local certificate thumbprints, and so on. What happens during a deployment? The following steps typically take place during a deployment. When a deployment is initiated by MShell, the first step is to validate all of the configuration. Configuration files and components are reviewed for completeness and presence, and not correctness. In other words, any changes to variables inside of these files will be accepted by the system as long as the variables are defined. MShell is simply checking to make sure that the necessary variables are defined and not whether or not the values specified for those variables are correct. Once the validation is complete, the validated components and its configuration are uploaded into the image store. The image store is a Windows Azure storage account and is accessible by both the operator and all of the hosts on the cluster. Once the image store upload is complete, a deployment request is created on the primary CM through the command gateway. The command gateway will then analyze the deployment and determine whether or not it contains any Windows Azure infrastructure changes. If it does, then the primary CM, using the MR protocol, will request a rollout managed by the Windows Azure Fabric Controller by notifying RDFE. Once this infrastructure action is complete, then a regular SQL Azure on Windows Azure controlled rollout of the components will begin by upgrade domain. Assuming the rollout is successful, then the rollout will complete and the MShell process will be notified that the rollout is complete. The configuration files used in SQL Azure get consolidated and moved around in a bunch of different ways. There are 7 different configuration file types involved in building the application infrastructure for SQL database clusters running on Windows Azure. The first 5 types are created by the Microsoft engineering team, and these are the types that are included with the build. Almost every service running within SQL Azure on Windows Azure will have files of these types, such as application XML, global settings.xml, service settings, and application SKU.xml. Every environment will also have a file called application alerts.xml. On a per environment basis, there is an application override.xml. This application override can specify the configuration of any variable that is found in the application XML files in the environment for which it is intended. For example, there is a front-end environment and a back-end environment and a management environment. There is an application override.xml file for each one of these environments. The variables found in each one of these application override.xml files apply only to that specific environment. There is one cluster XML file, and this cluster XML file describes the overall architecture of the system. And this cluster XML file specifies the overall infrastructure image of the system, including items such as the node counts and role counts, general firewall rules, general command gateway locations, the location of the image store, and so on. All of these files are generally merged together and moved around into a different set of files. A number of them are consolidated into the csconfig and csdef, which are typical Windows Azure constructs. Some of the other ones are passed along without much change to the services that require them. The application XML found for most services will enumerate all aspects of the service, including general role definitions, service lists for those roles, service definitions, endpoints, and what certificates are required by that service. The application XML defines the general what of the service model for the entire environment. What runs where, with what executables, listening on which ports, and with what security aspects, and so on. The service settings XML file, found with almost every service, will define configurable parameters at the individual service level. These parameters will also define whether or not they must be overridden. If a variable needs to be overridden, then must override will be set to true. If must override is set to false, that means that the variable can be overridden, but isn't required to be overridden. This file also sets the default values for these parameters. These are the Microsoft recommended settings and should not be typically overridden unless they are reviewed first by Microsoft. An example is presented below. These are the variables needed to operate a watchdog on the back-end environment. Each one of these variables could be overridden within the application override.xml for the back-end environment. However, unless there is some specific local requirement, in general, the default value should be accepted. The Global Settings XML file has a similar structure to each of the Service Settings XML files, but contain the configurable parameters that are consistent across the entire environment. Like their equivalents in the Service Settings XML file, they also indicate whether or not they must be overridden. An example presented below are some settings that are generally considered to be local settings, such as the gateway and cloud ports used below. When must override is set to true, then it is required that these variables be overridden within the application override.xml for their respective environments. The validation step that mshell performs, which was referred to earlier, will check these values and make sure that they are overridden. The application SKU.xml will define the actual configuration of services that are consistent across all production clusters. They may contain any configurable value available to the system. This includes values that were present in Global Settings, Service Settings, or Application.xml, and they are identical in format to each one of these other files. In general, the SKU is meant to define parameters that are specific to a particular machine architecture or type, or generally applicable to a large series of clusters. An example would be settings that are specific to a type of disk that is used generally across all clusters. The application alerts.xml file will define the base set of alert conditions for the environment. There is one application alerts.xml file for each environment. This file will define the evaluation frequency, the failure threshold, and suppression time for each alert that is defined for this environment. Any alert that is set in this file can be overridden in any of the SKU files or any of the application override XML files. New or custom alerts are typically defined in the override files first, and then eventually moved into this file during the Microsoft build process. The application override.xml file defines configuration items that are specific to a local SQL database cluster. As stated before, these are typically variables like local DNS name or local thumbprints. However, they may contain any configurable value available to the system. They have a structure that is identical to the application SKU file provided by the engineering team. Currently, the application override file changes rather frequently, but Microsoft is moving to a model where most of the configuration will be specified in the earlier configuration files. Finally, the cluster XML. Cluster XML provides the information about the infrastructure of the SQL Azure database cluster and passes it to Windows Azure during deployment. Cluster XML contains role definitions, role counts, which machine SKUs are to be used, and these SKUs refer to the Windows Azure SKU definitions, where the command gateway endpoint is and any relevant firewall settings for that endpoint, operating system versions, upgrade domain and failure domain information and count, as well as other items such as the location of the image store, general firewall rules, and so on. Combined with the application.xml files, it is responsible for telling Windows Azure how to deploy the SQL Azure database cluster. The cluster XML file in general defines the topology and infrastructure of the cluster as seen by Windows Azure. During any deployment process, mshell will consolidate these files into a series of smaller files, such as the CS configuration and CS defs shown here. It will also pass along a single copy of items such as the application.xml with the overrides contained within it. The config store. The config store contains all operator-owned configuration files, such as cluster XML and the application overrides. Both MShell and XDS will access the config store to retrieve cluster information, as well as any other information they need about specific services. Any changes to the production cluster are made via the files stored here. The config store should be part of a source control system that provides general file access and update abilities, as well as auditing capabilities. The config store needs to be accessible from all client machines that will run XDS and MShell in order to manage the cluster. The config store needs to have the following structure, as shown here. At the top level, there will be a name for the cluster, and this will be the common name for the cluster as seen in XDS and as used in the cluster commands for MShell. Underneath that cluster name, there should be a folder named config, and underneath that folder, there should be one folder for each environment: backend, front end, and management. The application override XML files live underneath these folders. Cluster XML will live underneath the config folder. Next to the config folder, there should be another folder named data. The structure for this folder and all of its contents should come from the initial install provided by Microsoft. And the structure should not be altered or changed in any way. The cluster XML file must exist directly under the config directory for a given cluster. MShell. Quick review of MShell. MShell is the primary tool used to deploy anything on SQL Azure on Windows Azure. It is a packaged set of PowerShell commandlets that are tailored to fit SQL Azure on Windows Azure clusters only. All MShell deployment commands will require the config store to be available in order to access the cluster information and manage the deployment. Specific MShell commands are covered in detail in the Tools module. Next, we will complete a walkthrough of key configuration files: cluster XML, the application XML, the application override.xml, and a file called Azure Regions.xml, which will be found in a data deployment. As mentioned earlier, the cluster XML contains all infrastructure settings for Windows Azure clusters. The application XML will contain all default settings for applications in an environment as determined by the product group, which in this case is Microsoft SQL Azure. This file is not to be modified. The application override.xml, one for each environment, can be used to override any settings that are found in application XML with environment-specific configuration settings. Azure Regions.xml is typically modified during the initial deployment with data center and cluster-specific URLs and information. The Azure Regions.xml file is used by each cluster to figure out which region it is a part of and which region it should be responsible for. And these regions are defined by Windows Azure. They generally refer to geographic regions. For example, Microsoft hosts a number of regions in the North Central United States and South Central United States, as well as Europe and Asia. These are all regions defined in this Azure Regions.xml file. A general overview of certificates used on SQL Azure on Windows Azure. Windows Azure SQL Database requires a large number of certificates to maintain secure communications. There are three major categories of certificates used on a SQL Azure on Windows Azure system. There are certificates used to secure intra-service communication, and this is communication between other Microsoft services or Windows Azure services. An example would be communication between SQL Azure on Windows Azure and RDFE, SMTP, TFS, the provisioning system provided by Windows Azure, and so on. There are certificates used to secure client connectivity. These are certificates such as the data, admin, and management certificates. And these certs are used to secure communication between any client external to Microsoft and the cluster itself. For example, the data certificate is used to secure the TDS channel between a client application and SQL Azure on Windows Azure. Then there are administrative certs, which are used for access control. These include items such as the master and command gateway authentication certificates, the monitor and operation certs, and so on. These certificates are only used for internal management purposes and are not exposed to the outside world. Intra-service certificates are typically global and do not change between production clusters. If you are operating multiple clusters, these will typically be the same between both clusters. However, ICA customers will have certificates specific to their installation. Most of these certificates will be configured in the front-end application override XML file, with the exception of the SMTP and TFS certificates, which are configured in the management environment application override.xml. The client connectivity certificates are cluster-specific. The data, admin, and management certificates provide secure endpoint for all customer communications to the gateway and management service nodes. These are configured in the front-end environment application override.xml. The administrative certificates are configured in three different locations. The master certificate, which includes general deployment, encryption, and RDP functionality, is defined in the cluster.xml file and in the front-end application override and in the management environment application override.xml. The command gateway authentication certificates for operator, support, and monitor functionality are defined in the management environment application override.xml. The master certificate is used to perform any action with the Windows Azure Service Management API. It is identical to the master certificate used for any general Windows Azure service. It is required to authorize application deployments and perform all other maintenance tasks associated with the subscription, such as changing role counts or node counts. In general, on the SQL Azure on Windows Azure system, it is also used for the encryption of secrets within the files. This certificate must be uploaded before any deployment activity using mShell or CSManage can occur. This certificate is typically uploaded using the management portal that Windows Azure provides. The Command Gateway Auth certificate. The Service Management Platform limits administrative access with a feature called Command Gateway Auth. The Command Gateway is the portal to the Command Gateway is the portal to cluster data and all administrative functions. The Command Gateway limits access with a trio of certificates. Any user presenting the operator certificate to the Command Gateway will have the highest level of access and will be able to run all commands, including items such as deployments and rollbacks. An operator presenting a support certificate will have a medium level of access They can typically run most commands involving repair and monitoring, but cannot initiate items such as deployments. An operator presenting a monitor certificate will only be able to have read-only access to the service states. Command Gateway Authorization. Any tool which accesses the command gateway, such as XDS or MShell, will check the local machine certificate store for one of these certificates and present it when connecting. If the appropriate certificate isn't present, then access will be denied to the command gateway resource. Below is a list of functions that is allowed by default using the operator certificate. The operator certificate will allow the operator to perform just about any action available through MShell, including repairs, infrastructure actions, node status, rollouts, rollbacks, and general environment management. The following is a list of functions allowed by the support certificate. In general, that will allow all monitoring functions plus a few additional commands, such as the ability to generate new alerts and update general node allocations. An overview of the Service Platform Bootstrap process. The Bootstrap process first deploys the management environment. It does this by allocating VMs from Windows Azure for all application environments configured in the cluster.xml. Once the management environment is deployed, the Bootstrap process will then deploy all SQL application environments specified in the command string, such as the front-end and back-end environments. Fault domains and upgrade domains are created during the Bootstrap process. Below is an example of a service with 3 fault domains and 3 update domains specified. The count of these domains would have been specified in the cluster.xml file for this cluster. A fault domain is a Windows Azure construct that is meant to guarantee complete availability and redundancy between a group of roles or nodes. An update domain is a SQL Azure construct, which is meant to ensure that a rolling upgrade can take place without triggering the failover of a fault domain. Therefore, they are not layered on top of each other, but are essentially orthogonal to each other. This is a general overview of the Bootstrap process. Windows Azure starts with a series of vanilla host machines and will begin by initiating the Cluster Manager or CM role runtime. Once the CM role is up and a ring is formed between them, then the service management platform is now ready to accept additional environments. Some auxiliary services will then be deployed for the management environment. Once those have completed their bring up, then extra application domains will be added. These would be the front-end and back-end environment applications.